Hi everyone and welcome back to Maths and Physics with Mr. Simons. Today's grade 12 sequence and series lesson. Now we're dealing with the surprise exam question that we just pop in is can you, when given the sum formula, so we've already given or created the equation, you must be able to calculate the first three terms, and this normally is a 6-mark exam question. So it pops up as a surprise. It's not something that textbook has a lot of, so we don't practice a lot of it, but it does appear in exam. So that's the difference between doing classwork and exam work, right? But it's work, you know. I know you can do this, right? So determine the sum of various terms. And say the sum of the first n terms for arithmetic series is given by Sn equal 5 over 2n squared plus 7 over 2n. Right, now easy mark for 3 marks. Can you determine sum 1, sum 2 and sum 3? Right, so all we're testing is wherever n is, can you substitute 1? Wherever n is, can you substitute 2? Wherever n is, can you substitute 3? So there, for the first one, 1, 1, alright. So that 1 squared stays 1, 1 times 5 stays 5 over 2 plus 1 times 7 stays 7 over 2, 7 plus 5. So the denominators are the same. We add the numerators. So 7 plus 5 gives me 12. So there 12 over 2 and 12 divided by 2 then gives me 6. So that's the sum to one term. Alright, for two terms, wherever n is, now I've got 2 squared and there 2. So 2 squared gives me 4. 2 there would give me 2. So 4 times 5, 2 times 7. Take note, we only multiply it on top because it's technically 4 over 1. So top times top and bottom times bottom. 2 times 1 stays 2. 5 times 4 would give me 20. 7 times 2 would give me 14. Now from there I could have just said 20 divided by 2 is 10 plus 7. But I want you, some people of you all need to improve your fractions. So there, the denominators are the same, so we add the numerators. 20 plus 14 gives me 34, and then 34 divided by 2 would give me 17. Right? For sum to 3 terms there, you see that would become, wherever n is now, put 3 there, so 3 squared and 3. 3 squared is 9, so it becomes 9 times 5. Not 9 times 5 and 9 times 2, only 9 times 5, because that is 9 over 1. 3 times 7. Alright, so there you see 9 times 5, 3 times 7. 9 times 5 gives me 45. 3 times 7 gives me 21. Now you see there, if I go now the route previously that I said I can follow, I'm going to end up with a decimal fraction and a decimal. You normally have a calculator. I grew up without using a calculator, right? So 45 plus 21 gives me 66. Now 66 divided by 2 would give me 33. So the sum to one term is 6, the sum to two terms is 17, and the sum to three terms is 33. Now the process we're going to do next is to ensure that you understand how to use these three sum values to get the three first terms. So that is the surprise for exam. So determine term 1, term 2, and term 3. So you see I have sum 1 equals 6, sum 2 17, and sum 3 33. So very important, and remember, now follow me very carefully. Write it down, make sure you understand it. Term 1 will always be sum to 1 terms, because it's just one term that we've added. But term 2 would be the sum to 2 terms minus the sum to 1 term. So adding 2 terms gives me 17, adding 1 term gives me 6. So I subtract that 2, I get the term in between that was used to go from 6 to 17. For term 3, it would be the sum to 3 terms minus the sum to 2 terms. So that 3 you need to understand. So if I said I want term 10 would be the sum to 10 terms minus the sum to 9 terms. So term 1 then would equal 6. Term 2, 17 minus 6, which gives me 11. Term 3, 33 minus 17, which gives me 16. Right? 1, 2, 3 marks. Right? 4 for the formulas, or can be 5. The previous marks that they all in all would have made it 8 marks. So there my sequence is 6, 11 plus 16, which will give you 1 mark for the correct sequence. Alright. Let's look at another problem. Alright. Now the sum of the first n terms of arithmetic series is Sn equal 5 over 2n squared plus 7 2 over n. Is the series arithmetic or geometric? Prove your answer. So we've already now found 6, 11 and 16 as the first 3 terms. So first test, if it's arithmetic, term 2 minus term 1 must equal term 3 minus term 2. So 11 minus 6 must equal 16 minus 11. So that gives me 5 equal 5. Alright? So therefore, because I have a common difference that is the same, this here is referred to as a arithmetic sequence. Alright? Next problem. Alright, the sum of the first n terms of arithmetic series is that. So instead of giving you what we did previously, I can ask it all in one go and say determine term 15. So I need to know term 15 would equal the sum of 15 minus the sum of 14 terms. No? Right, so sum of 14 terms, wherever n is, I'm going to put 14. So there 14, 14 squared, 14. 14 squared times 5 would give me 980. 14 times 7 would give me 98 over 2. Right, 980 plus 98 gives me 1078 over 2. If I divide it, I get 539. So that's the sum to 14 terms. Sum to 15 terms, substitute 15. 15 squared 225 times 5 gives me 1125. There 15 times 7 would give me 105. 1125 plus 105 gives me 1230. Divided by 2 gives me 615. Right, so now having that 2, I can say the term of 15 equals sum 15 minus sum 14, which gives me 615 minus 539 equals 76. So 1 mark for correct formula, another mark for correct values, 1 mark for correct answer, and there 1 mark for substitution. So we can test this instead of asking what we've asked previously, all in one go. All I want you to do is work through this. Find another past paper. I'm going to upload some of my own later on, or the videos that's coming on. Please ensure that you know how to work from a sum formula to getting a term. Alright? I wish you nothing but the best. I'm happy that you are still here, you're still following me, you're still working towards your own success. Alright? Together we can achieve anything. Alright? I love teaching, I love helping learners. And I hope I'm helping you. Please like and subscribe. God bless. Bye.